All right, so today, mostly what we want to talk about today is a phase shift or a translation of y equals a sine of x or y equals b cosine of x, okay? So what I mean is we're going to just take either the roller coaster, and I like to call it the roller coaster because it's easy to understand. Because if it's a roller coaster, it's a sine, or the water slide, which is the cosine, right? Tomorrow we'll talk about the other ones, tangent, cosecant, secant, and cotangent. But there's not a whole lot of applications for any of the others. For sine and cosine, the applications are just all over the place. Your cell phone alone, right? I mean, everybody's got a cell phone. You get your information from your cell phone traveling in microwaves. They're microwaves, right? Why does your phone go off when mine doesn't? Because your signal is slightly different, right? It's modified enough that you've got a tiny little receiver, and that microwave hits your phone, and your phone rings, right? The texting, all that's unbelievable what we have in technology today. But everything, including text and videos, everything travels in waves through this space we live in, which is kind of weird to think that we're being bombarded by billions of waves right now, right? Crazy. So what I want to do, though, is take a look at these graphs. So there's a few things that I want to give you. So the amplitudes are usually pretty easy. But if you have a hard time finding the amplitude, because sometimes the graphs will be shifted, and you'll have to figure out what the amplitude is. Well, it's just going to be the average between the highest and the lowest for the amplitude, which is the max minus min divided by 2. Okay? The frequency, if it's hard to find the frequency, it's simply going to be 2 pi, always 2 pi for sine and cosine, divided by the curve width. So if we go over here, we want to find out what's the frequency. We take the curve width, 1, 2, 3, 4, 5, 6, 2 pi divided by 6, we can get the frequency, okay? Now the horizontal shift, again, because it says subtract, it's always going to be the opposite, right? And the vertical shift is just up or down, okay, which we've done before. So let's graph example number 1. So if you need graph, anybody need graph paper? If you do, raise your hand. I've got graph paper. Anybody need graph paper? Okay, I've got, okay, there you go, graph paper. Graph paper. Graph paper. Graph paper. Here's a whole bunch. Graph paper, anybody else? Okay. Here's a whole bunch. Just pass around what's left over yours, okay? So, thank you. So if I take a look at example 1, when I take a look at 1, I do a couple of things. First of all, I know what the sine looks like, so before anything, the first thing I'm going to do is I'm going to graph this. I know that's my sine. My sine curve is my roller coaster, right? I know I'm going to go from 3 to negative 3. And the graph I need 2 curves, so I need to look at the new, what I call the new period. So the new period is going to be 2 pi, I'm sorry, the frequency, 2 pi divided by this number here. This number here, okay? So divided by 2. All right, so I'm going to start putting that on my paper a little bit more neatly so it looks better. And I'll move it at the end. So I'm going to do 2 graphs. I'll do the standard graph and then I will shift it, okay? So I'm going to go ahead. It's going to be pi. Sorry, it's a little sloppy there, Lauren. Yeah. Sure, go ahead, Kai. So I know that I'm going to have to go from 3 to negative 3, right? 3 to negative 3, because the amplitude's 3. I need this shape, my sine curve, between 0 and pi. Okay? So the new period is pi because it's 2 pi, always 2 pi, always 2 pi divided by the frequency. So the new period. So I'm going to go, and I'll put in my pi halves, pi, 3 pi halves, 2 pi. Okay, I'm going to do that for sure. One of the things I'm going to continuously do, and I think you're going to see more and more why I do this, but I always leave 1, 2, 3, 4 squares, don't I? And you're going to see today why I always do that, okay? It's going to help me when I graph, okay? So then, in pencil, I'm just going to sketch in this graph. It's a sine curve, so it's, remember, 5 points. Remember I talked about 5 points? I'm going to put in my 5 points, my beginning, my end, my middle, my first quarter, and my third quarter, right? I like to use my 3 points. So starts at 0, ends at 0, but at pi, right? Halfway through the curve, it's at 0 at pi halves. That's obviously pi fourths. So pi fourths, it's up to 3. 3 pi fourths, it's down to -3. And I'm just going to sketch this in because I'm going to move this. And I'll do it again because I need 2 of them, okay? So I've got my one curve. And I'll sketch in a second curve in a second, okay? I'll let you catch up. So I know I need the sine curve, 3 to -3. I need 2 of them, therefore they both have to be 0 to pi, pi to 2 pi. You get 2 of them in, right? So the second curve, I'll sketch it again. I like my 5 points. Helps me do a dot to dot, really, right? Okay, and that's going to be 5 pi fourths, 7 pi fourths, looks like that. How am I doing? Want you guys to understand this. So I ignored all the other right now because I'm going to move it. Just ignoring that right now. But I need the basic shape before I move it. So the basic shape goes from 3 to -3. I've got to get 2 curves in 2 pi. So here's my 1 curve, my 2 curves. I like the dot to dot because then it helps me graph. Okay, now, the next piece is just to move it forward pi 8. And that's why I like my squares, because pi 8 is really 1 square. Ready? Pi halves. Pi fourths. Pi 8 is just 1 square. So I move every point forward, pi 8, and then I move it down 2. So I'm just going to take every important point and just take it and move it. We're going to go pi 8s to the right. And then we're going to go down 2. So I'm going to go, all right. Oh, this isn't the color pins I wanted, but that's all right. Let's just use, I'll use red. I'll use the whole thing in red.
Is it moved to the left or the right?
Opposite direction.
Okay.
Good. Good question. Always the opposite inside, right? So when you look up here, right, you got the negative. Remember the silly little dance? Carly, remember the dumb little dance? So I'm going to go 4 pi 8s and then down 2. So this point right here, this point at the origin went right there. And all of the points are going to go 4 pi 8s and down 2. 4 pi 8s down 2, 4 pi 8s down 2, 4 pi 8s down 2, pi 8s 2, pi 8s 2, pi 8s 2, and pi 8s 2. Okay, I'll let you catch up, okay? And then I'm just going to sketch in the curve. Every single one of my significant points is moved forward pi 8s and then down 2. So if I were to sketch in my curve, it's going to look something like this. And of course it keeps going and going and going, right? But there it is. That is the graph. All right. I'll wait for you to give me thumbs up before I move on to the next one. Okay, I see 1 thumb up, 2, 3, 4. I'll wait for you. I want to make sure everybody gets it. Okay. Okay, let's take a look at example 2. So on example 2, first of all, I'm going to graph, before I do anything, a cosine. So I know it's going to look something like this. Here's my cosine curve, right? It's a water slide. Here's my cosine. From 2 to -2, there's my amplitude. So before I do anything, let's just try this. Y equals 2 cosine pi force x. We're going to do that first, and then we'll move it. We're going to graph that first, and then we'll move it. All right, so now the period's kind of weird. So what is the period? What's the width? So the period, I'm sorry, I keep saying period, but I mean the frequency is, no, I know the frequency. The period is 2 pi, always 2 pi, divided by this number.
Can you talk a bit over?
What's that?
Can you talk a little bit?
Sure can. So to find the new period, I'm going to take always 2 pi, and divide up into pi fourths, okay? So when I do that, the pi's will cancel if I go 2 pi over 1 times 4 over pi, right? Invert and multiply when I divide. Okay, the new period's 8. Not 8 pi, but just 8, just like the number 8. So when I do my axes, I'm going to do my axes in terms of ones, okay? So my period is 8. That's my period. All right.
What was the period on the last one?
It was pi.
Right.
Good question. Keep asking, Carly. All right, so let's see. First thing I want to do is graph just this curve. All right. I'm going to go from 2 to -2. 1, 2, 3, 4, 5, 6, 7, 8, right? Not pi's, but plain old 8, so it's stretched all the way out to 8, okay? Might be 8 seconds, might be 8 nanoseconds, who knows, right? But you're going to see more and more in the applications, like in electronics, that these numbers are going to be seconds, time, okay? Okay, so then, let's put this graph in here. So I know, again, I've got my 4 important points, so I'm going to start with, it's going to start here at 2, and it's going to end at 8. Halfway through is the middle, it's going to be down at 4. 1/4 of the way, it's going to be here at 2, and 3/4 of the way, it's going to be at 6. I'll wait for you, okay? So I took my 5 significant points and I put them there, 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 and there, okay? Wait for you guys to go ahead and write that down. So the next piece of this will be simply to move this graph. So we're going to translate the graph. We're going to go back, we're going to go to the left 1 and down 3, okay? I can do that. I go left 1, down 3, 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 and now my cosine curve looks something like that. So we shifted it, didn't we? How am I doing? Okay, I got one kind of thumb up. It's up. Is it sideways? Anybody sideways? You guys, thumbs up? Anybody sideways? All right, I'm doing all right then. Okay, let's turn the page. Now, on equation 3 and equation 4, let's make the equation. So, first of all, I want to say flat out, there are 4 correct answers. 4 correct answers, okay? It just depends on where you start. It depends totally on where you start. You can either call it a sine, but that means you probably got to start there. Or a cosine, that means you got to start there. 4 correct answers, and all answers are going to be fine. I'm going to start, for me, I think the easiest place to start is right there. You okay with that? If I start right there? Because I can see a sine curve, can't you? If I start there, it's my roller coaster. Whee! It's 11. I'm such a dork. My wife calls me that a lot too. It's okay though. She goes, "You are such a dork." I go, "Yeah, okay, whatever." Okay, so you guys okay with the fact that I'm going to call it a sine curve? Okay. I'm going to highlight it so we can definitely see it. Okay. Let me get my highlighter out here. So, all right. I need a pen that's going to work for me. Come on. Okay, so here it is, right? There's one curve. So I'm going to start off with y equals sine. Just start y equals sine, right? Amplitude, 3, everybody agree with 3, right? I can see it goes 3, negative 3, I agree with that. Now, to find the frequency, which is b, it's going to be always 2 pi divided by, because that's its normal width, divided by this curve width, by the curve width. Well, that's 2 pi divided by, let's see, what is the curve width? How wide is it from here to here? What's the curve width? It is pi. Do we agree with pi? Mm-hmm. So, my frequency is 2. Scoot over. All right, so my equation, y equals a 3 sine of 2x. But I need to do this because I get to do the fancy dance. Right? It's inside the parentheses, and we moved it pi 6 to the right, so we're going to go minus pi 6. Do you agree with that? Okay, that's all we have. That will be that equation. Minus pi over 6. Okay, thumbs up. Kai, I'll give you my notes when I'm done, okay? All right, shift up number 4. All right, so now, let's see. Is it going to be a roller coaster or a water slide? Depends on where you start. Yeah, in fact, I even have a little spot for you. I'm going to call it a water slide too. I think that's the easiest. It's kind of hard to do the roller coaster because it sure looks like maybe the sine curve starts, like where's the middle of this thing? Maybe right? Yeah, it starts there. It starts there. But we could call it a sine. It looks like it got bumped maybe 1/2, but I mean, it'd be easier just to call it a cosine and move it forward 1. Everybody okay with that? So let's call it cosine. So let's start off y equals cosine. Now the amplitude. Well, if you can't figure it out, got a little formula. Max minus the min divided by 2 is one way to get the amplitude. So I'll go max, which is 3, minus the minimum, which is 1, divided by 2, which is 2 over 2, which is 1. And maybe you saw that if you find the middle of the curve. And I don't know if you can see the middle of the curve, but the middle of the curve is right about here, right? You guys see the middle of the curve? And if you can see that, it just makes it easier for you. So I'm going to put a 1 right there for my amplitude. Now, the frequency, which is b, is 2 pi divided by the curve width. Okay, Greer's got already. Greer, did you get 6? So we got 1. Here, let me highlight. Yeah, it is 6. I'll highlight it though so everybody can see it. So let's take our water slide. All right, from here to here is our one full curve. 1, 2, 3, 4, 5, 6. What Greer said. So the frequency is 2 pi divided by 6, which is pi thirds, right? Or is it 7?
I think it's 6. So I'm going to go pi thirds, parentheses. We've got a horizontal shift, don't we? Our horizontal shift, we're going to go x minus 1. And then it got moved up, didn't it? In fact, if you can find the middle curve, it got moved up 2. Okay, so I'm going to go plus 2. If you can't find the value of k, it's always going to be the minimum plus the amplitude. Okay, if you have a hard time seeing that it got bumped up 2, right? I mean, the whole curve, visually, the whole curve just got moved up 2. You guys see it?
Yeah.
If you can't see, it's the minimum, which is, what's the minimum? 1, right? Plus the amplitude, which is 1. 1 plus 1 is 2. And that always works. Find that vertical shift. So, there's my equation, right? What do you think? Okay, so we got lots of time. We got almost a half hour. So let's get working on this while I'm here to help, okay? So just the odds. You guys see that?